And I want to start with something that also excites me to learn more about is like you're working at DeepMind, one of the coolest labs, like as a researcher, like when you are in your PhD, like it's like places like this that you want to be working at. So in your terms, like when you join DeepMind from academia, what do you think are the most amazing aspects that you feel working at DeepMind is? And I know this is like a personal opinion, it could be just specific to you. What excites you most working at DeepMind?
Yeah, that's a good question. I mean, I think there are a lot of different aspects, and as you said, it might be very subjective and very personal kind of decision and view on things. I think a couple of things that many people might agree with or might agree on is, so first, I think there's just like an incredible amount of talent in general. And this, of course, is on the research side, right? So if you want to do a PhD, you of course select your PhD by like who you want to work with, what you want to work on, like what does the institute do? Is there kind of a lot of resources? Do you have like famous researchers from there? Do you have like to get people prizes and so on, right? A lot of things you look at. And at DeepMind, you have a lot of that. You have a lot of smart people, not only at one organization, but to a large extent also in one city, right? In one office, essentially. And this makes a lot of difference, in my opinion. And with COVID, of course, there's a lot of discussion about remote work and so on. And but it makes a difference because, like, a lot of the conversations you have, kind of during lunch, during events, you have with people that are very accomplished in machine learning, computer vision, NLP, and so on. And this, of course, has a lot of benefits. I mean, you have cool projects, you have cool collaborations, we're always on the edge of time. But for me personally, it also means that there's so many people that know more than me and have more experience than me, and that I can learn from in various ways. And this doesn't only apply. So I'm of course talking a lot about the research because the research is what you publicly see from DeepMind. But I mean, the same is true for engineering we do at DeepMind or kind of Alphabet in general, and also beyond that, right? I mean, organizational kind of program management, product management, and so on. There are just a lot of smart people and a lot of people that are very experienced in these things that you can learn things from. And I think for me, this was, I think, the key thing. And of course, I had the advantage of having done an internship, so I kind of knew some of the people that I would be working with. And when it came to the decision, I thought, yeah, I mean, are these people that you want to work with for a couple of years? Are these people that you can learn from? And definitely, right? I mean, not only because they're smart and accomplished and so on in my field, but some people I work with also have very different background, right? Come from different disciplines or have worked very extensively on specific topics that I don't know a lot about. And so for me, it was kind of a great opportunity to just like join an organization that had just like a lot of opportunity to learn and grow basically during every lunch, basically during kind of in every project. And of course, like day-to-day work is you have your project and you can't just like work at the same time with everyone and learn from everyone. But it's still nice, you know, and there's kind of a lot of talks going on, and of course to some extent it also attracts external kind of talks coming in and so on. So I think that was for me the key factor. Besides that, and this also goes a bit into industry versus academia in general. But for me, I like the engineering part. I mean, we just talked about, right? I mean, I know a lot of PhD students, and this is really not kind of meant in a negative or positive way, right? It depends on during your day, what do you like working on? And there are people, and I would count myself, and from what you said, I would count yourself as that enjoy the engineering part, right? That like to spend time on like having nice code and optimizing a bit and running a bit faster. And as well, there are people that prefer to do the writing or the presentation, and that are not too keen about learning about the next quantization scheme and the new GPUs and how I can run it on the next cluster and so on. But I always like the engineering part, and there's of course great engineering talent at DeepMind too. and a lot of great tools, and DeepMind values engineering to a large extent. And I like that. I think the engineering is valued a bit more than, or significantly more, in my opinion, than in academia. And it's one of my strengths, so it was very natural this was a kind of a very good additional point. And then another part is also that I knew that but this might also be kind of this might also be due to kind of the stage of career you, like in a PhD, you usually work on your own projects. And then, of course, as a postdoc, as a professor, and so on, you have bigger and bigger projects. You have more and more collaborators. But I felt DeepMind has a nice organizational structure where it facilitates working in bigger teams. I would like to, this was a contrast to my PhD, where kind of a lot of projects were driven by me, and were kind of individual projects and so on. And I wanted to try that out. I really was curious to work more in larger teams on like bigger projects, and longer term research problems and so on. So I think these were a couple of the key things for me, really. But again, we talked about like coincidence before. I was also lucky that the people I worked with during my internship, we got along very well. We are kind of on the same page, and I think that's kind of a main, or like a significant factor as well, right? That I like the culture, I like the team, and so on. So these are of course very subjective, right? I mean, people I get along with, that doesn't mean that you get along with them, but well, personally for me, of course, that's a big factor.
Yeah, and I think the more you are in your research, the mental rigor of your teammates matter a lot. So I think in research, I've seen like it's the idea of thought process is very contagious. If you have a set of people who are approaching a particular problem in a certain kind of way, that's very addictive. And if you find the perfect set, like it motivates you, because as a solo researcher, like I don't know, like unless you are like a brilliant person like Einstein. I don't know if Einstein worked solo or not, but I think most of the people that I would know have come up with thoughts or works that has been really, really critical, and who have always worked in groups, because like a fantastic idea cannot be just a creation of one solo. So I think, and when you're working on, and I would assume like DeepMind just doesn't work on just one very narrow topic. They have like a very bigger impact. They're trying to work on something that's applicable to not just computer science domain or AI domain. They are applying it on real world, and that just begets the problem that, okay, I need to be much more inclusive of thoughts and inclusive of expertise. And I think that's why I think having people who align with you on a mental level is really important, and especially in a research lab.
Yeah, definitely. I mean, I agree. It's like, it's also learning different ways of thought, of thinking, right? Different ways of developing ideas and so on. Do you mostly work on like in your PhD, the projects? Do you usually have a lot of collaborations with PhD students in your lab and stuff, or?
Yeah, I think I have been fortunate enough to actually, like, I would say I have the least amount of people I have interaction are computer science students, because my professor who funds my research is actually, she's from industrial engineering background. So I mean, she had her background in mechanical, then she did her PhD in industrial, and nowadays I think since the last 10 years or so, she has been heavily invested in medical AI. And so obviously a lot of people in my lab, they are from data science disciplines, industrial engineering, and there are just a couple of computer science students. And I frequently communicate with people from medical background. So these are like MDs or people who are like experts in medicine. They just understand AI for the sake of like, it works, it does classification, it gives you F1 score, prediction score, accuracy, and all those kind of stuff, but they don't understand the working behind it. So I think it's like a constant juggle. And what I feel very useful for me is like, because I have to summarize my work in 3 different genres. So when I'm working with my friend who's like a computer science student, I have to talk to him in a certain way that, yeah, this is the nitty gritty details of what's going on into the model. No BS about it. But then when I'm summarizing these things to my professor, who necessarily doesn't know how exactly data augmentation works, but she knows most of the stuff so that she can critique. And then when I'm communicating this to a doctor, he or she doesn't really care about what model I use. He doesn't care what ResNet 18 means and what ResNet 52 means. He just knows that it's a black box. What do I do with it? So it's like this frequent, like changing the hats into different topics really helps me motivate and like maybe get some new ideas that if like don't get stuck up on data augmentation too much, like the problem is much more bigger at hand or something like that along those lines. So yeah, I mean,
yeah, that sounds great. I mean, I think it can be challenging, so I get that point, but I think so it's not something you optimize short term, but I think it's a very valuable skill to learn, that you like find the right level of abstraction, the right way to phrase it, depending on who you talk to. And yeah, I mean, just like mirroring that to in the collaboration with IBM Research, for example, that was the same, right? I mean, there was somebody sitting there, probably with an electrical engineer background, telling me about like how static memory works and like what's the voltage, and I was sitting there trying to explain. And it really took a while to kind of find the right vocabulary and the right kind of language. But it was very rewarding once you were on the same page and you could actually work. So yeah, sounds like you have like a really interesting setup.
Yeah. And I think, like you said, like it brought, even for in your case with IBM, like it helps you figure out a problem that has like a real impact, and it also helps you with your thesis, right? Like you said, like you connected it somewhere back to robustness. So I don't know if it helped or not, but like in some cases it might also help you induce better thoughts when you're working with robustness. Like you might be stuck up on some problem, and it gives you a different perspective that, okay, what if I consider this problem like this, and it helps me solve the problem. Oh, but you also go back to your original thesis and saying, oh, why don't I just borrow this idea into my this particular approach? So it's very translational, like the idea of getting the meta insights from research is very translational. You can take from one thing to the other one.
Definitely. So, and maybe tying it back to DeepMind, I just feel it takes commitment and it takes time to build relationships or to interact with people that have different thought processes or come from different backgrounds. But I think every time you do it and you invest the effort, it's like you have basically one more way of thinking in your kind of tool belt. And that's one thing where I think like just having a lot of smart people from different backgrounds is like a valuable thing. You can't learn like from all of them at the same time, and it's challenging. It's more friction at sometimes, but it's like if you do it step by step and you kind of invest time, I really enjoy kind of learning about these different ways of thinking and different approaches to research and so on. So yeah, for me this was always a try. I can always recommend making decisions at least partly based on the people or the researchers in a sense you are going to work with.
Yeah. And can you tell, I think, I mean, you would have some confidentiality over here, but can you tell more about, like you said you interned at DeepMind. So if you can share about like what did you work while you were an intern at DeepMind? And if at all, like I'll leave the stage open to commenting if you can, what you're working at DeepMind currently.
Yeah, I can't really talk about what I'm working on currently, but I'm happy to talk a bit about the internship project and at least the rough topics I'm interested in when I started last year. So during my internship, we were interested in uncertainty estimation. So as we discovered earlier, I worked a bit on uncertainty estimation during my PhD in terms of like this confidence capable adversarial training, where the idea was also to tell or teach a network to say, or teach a model to say, okay, I don't know, or you shouldn't trust my opinion here. And so what I worked on during my internship is basically a frequentist way of calibrating models to do something like that. And it's called conformal prediction. Conformal prediction is essentially a post-training calibration. So you have a fixed model, you take a calibration set, basically you split your test set, you have a calibration set, and you want to find out, okay, how do the model predictions look on this calibration set? And you do this in a way that allows the model to predict with uncertainty. For classification, this usually means that instead of predicting one label, you allow the model to predict like a set of labels. Yes, it's a confident set of labels. And you calibrate, so being very conjugate here, you can just do this by looking at the logits, and you just threshold the logits. All the logits above a specific threshold, or the classes corresponding to these logits above the threshold, are in your confidence set, right? And now you basically calibrate this threshold in a particular way on a calibration set. And then at test time, you get these confidence sets. And what usually happens is that these confidence sets, they are, of course, like a function of the model uncertainty. So how does your model perform, on which classes or so does the model perform worse, and so on. But it also reflects the data uncertainty, right? Is this more like a difficult example? Is it like an easy example? Is there noise on there, and so on? But this is a very intuitive way of integrating uncertainty into the predictions. And it's kind of a way of the model telling you what it knows and what it doesn't know, right? If you have a 10-class problem and you have an example and the model predicts only one label, then it might be pretty sure. But if it gives you like 2, 3, 4, maybe 10 labels, then at 10 labels, 10 labels doesn't give you any information. You can basically say, okay, the model doesn't know, right?
Yeah.
So it's a very intuitive way of quantifying uncertainty. I'm very fond of the method in terms also for analysis, right? We talked about class balance. Just looking at the set sizes essentially across classes will directly show you, okay, this class is more difficult because on average, the set is larger, right? And for the internship, we basically worked on, okay, how can we integrate this idea of conformal prediction, which in general is really entirely independent of the model, right? This could be a deep network, this could be a random forest, nobody cares. It could also be like an SVM or so. But we wanted to integrate it a bit more into deep learning, because what we saw happening is that during training, if you train a deep network, you optimize for cross entropy, let's say, right? So you optimize for a single decision, but then at test time, you don't use it for a single decision, prediction. You use it for these confidence sets. So there is kind of a mismatch there. And we basically worked on integrating or kind of bridging this mismatch a bit and integrating conformal prediction into the training routine. We call it conformal training. And you can show that this kind of leads to kind of better uncertainty estimates depending on what metrics you use. So it's basically an alternative to cross entropy training if you know that you're going to use something like conformal prediction at the end anyway. And maybe coming back to the previous question, this was one of these projects where I really learned a lot, because conformal prediction is, you can implement it in a couple of lines of NumPy or Torch or whatever. But there's really rich theory behind it. And this is a project that I probably wouldn't have done during my PhD usually. Also because it might not have been on the roadmap in the lab I worked in, because it wasn't really mainstream in computer vision or something back then. But yeah, my supervisors during the internship were interested in that, and they had very different background. Some of them really a lot of knowledge in stats in general, and I learned so much just by kind of going into a different topic, kind of putting on a different pair of classes and looking at problem differently, and then basically tying it back. Okay, I have all this knowledge on deep learning, let's kind of try to integrate it. So it was a nice project apart from like the research problem. But I really, and it's getting more popular, so feel free to have a look. There are a couple of people doing excellent work on like putting out libraries for conformal prediction and so on. So I really hope that it catches on a bit. But apart from that, I really enjoyed the project also from having an additional tool to use and learning more about the theory behind it and so on.
And maybe just like a general question. So like in academia, normally, like typically if you see like how the initiation point of any project starts with like a grant or something like that, that's like specific to PIs who normally write these grants, and they have like a real world problem that they are collaborating with. Like, for example, if you are collaborating with IBM, they get some inspiration, they try to nail it down in terms of research definitions, and then you as students work on it. How does it differ? So is it like similar to like you have a particular set of application at hand, and then you start working on the research definitions, and then we work on the idea of working on fundamental research, or is it like totally open-ended? It's still like an open thought by some principal scientist at DeepMind, and you, or as a student or as a scientist, you work on this one.
You mean how these kind of projects come about at DeepMind, or how these are initiated? Okay. That's a good question. I think there's no one right answer. For an internship, for example, I think it's to some extent a mixture of bottom up, meaning what you are interested in, what your skills are, and top down in the sense that there are, of course, specific topics that the team works on, right? And so it's, of course, more likely that you get inspired by kind of the people around you. And then, of course, there is kind of your supervisors or your manager and so on might have specific topics in mind because they think that something specific might be relevant for a larger project at DeepMind and so on. So I think it depends. So this is maybe the internship perspective. In general, I think there's always this balance between having bottom-up research. Research in academia is very bottom-up, right? It's basically you are interested in something and this might not be relevant at all, right? I mean, you can work on questions that might be relevant never or like in 100 years. Of course, the majority of researchers still like to work on something tangible, right? Solving cancer, trying to classify MRI images, something like that. But I mean, the organization is very bottom up, right? People find each other working on similar thing. They create conferences surrounding these topics. They have workshops and so on. It's a very bottom up process. In general, of course, within institutes, you have professors that like usually share a vision or like a general topic. But even as a PhD student, it can be bottom up to some extent, right? The exact technology you work with or how exactly you solve problems, it's like, or even the problems you tackle might be to some extent bottom up. But then there's also always kind of a top down approach. And I think at DeepMind or at companies in general, the structures differ a bit to academia, and that there's of course alignment. So I like to view it in a bit like if you join a research institute and you are in computer science, but the university is like famous for let's say medicine, then obviously you will find a lot of computer scientists working on medical AI, on kind of computer science for health and so on. Simply because there are people around that inspire you, people around that have problems, people that you meet at lunch and so on. And that's of course not different at a company. So, and at a company, the big things are, of course, you have products, you have customers and so on. So there's, of course, some inspiration from that going on. And this might be a bit more top down, that there are problems that can be solved and we can use ML to solve it. So I don't think there is a good answer. I also don't think it's super meaningful to go into the specifics of how it works at DeepMind, but there's a balance and there's a time dimension to it, right? Sometimes there's more kind of product focus, sometimes there's less. It depends on the team and so on. But in the end, it's still research, right? And the problem with research is you can't necessarily plan it, right? Yeah. You can't plan for LLMs to be the next big thing, right? Yeah. You can't plan for transformers. You can't plan for deep learning. It happens, and the community adapts, and companies adapt, and organizations adapt. Which is kind of also to some extent, it's also the nice thing about research, right? It's always and there's nobody has figured it out yet, right? If we knew how to perfectly do research, then it wouldn't be research to some extent, right?
Yeah.
I hope it answered the question a bit. I think it was a bit general, but yeah.
No, it definitely does. And I think that is one of the reasons I think these labs are really famous, because I wouldn't say famous, but it's like a desirable place for many of the researchers to be. Because if you see the standard scientist roles, like at some point, like when you graduate with a PhD, there's a certain set of expectations to be working on a problem in a certain way when you go out in the industry. And many of the times, if you don't find that, they try to revert back to academia because they want that kind of freedom of thoughts or something. But like labs like DeepMind, they have that much amount of I would say freedom, where you're still the same kind of person with same set of expertise and freedom that you have as a person working on research, but at the same time you're also aligned with certain set of applications, but just in a different. And to be honest, in the last, I think think it's specifically for progress in AI, like industry has been contributing much more, right? Like most of these works, I would say, came out of some fantastic projects.
Yeah, I wouldn't see it as a competition. I think a lot of the work originally also came from academia. There's still a lot of good work coming from academia, so it's definitely no reason not to do a PhD or stay in academia. I think it also personally depends also a lot of preferences, what is kind of better or worse in quotation marks, right? But yeah, I think there is kind of, so this freedom in terms of in academia that people like to talk about. This sounds negative, but there is never, I don't think there's like something like full freedom. You also have to write grants, and your grants, or you have to find a PhD position, you need to get paid. So if you want to work on X, but nobody's interested in X, you're not going to do a PhD on X. So I think the dynamics are different in a company. Of course, this is more explicit in terms that you have products, you have leadership, and so on that encourage you to work on specific problems. In academia, it's less explicit, but there's still a community, and the community as a collective decides what they deem relevant as of now. And there's always some sort of alignment happening, right? You of course have the freedom technically to completely disregard the community and work on something else. But I mean, we are still human, so this usually doesn't happen, right? You want to be part of the community, you want to contribute, you, to some extent, of course, you want to or have to kind of fund your life and your students, and you have to get hardware and so on. So I think it's this alignment is just happening in different ways in academia and industry. And there's also a time dimension, and of course in academia I would say it's easier, there is a bit more freedom in terms of that you have more decisions, because at least, like, maybe not as a PhD student, but I think academia also values that to some extent. In industry, it might depend on the company, it might depend on the culture, how exactly this is kind of lived. But yeah, I don't think it's kind of bad or good. It's like, for me personally, it's like, if there are interesting problems to work on, and people want me to work on that, be it the community finds it relevant, be it the company finds it relevant, then and I have freedom in terms of, I mean, there are freedom at different abstractions, right? But if I have freedom on choosing how to go about it, how to approach the problem, right? I think that's kind of, for me, that's kind of the key thing, right? If there are interesting problems that need to be solved, and I can have some freedom in going about solving them, then I think that's a nice place to be in.
Yeah, definitely. I think both of these fields bring in some kind of unique value to the idea of science or contributing to science, and like it's just a matter of like what works for you versus what works for the other one. As in, like, if you feel most comfortable contributing to pushing the boundaries of science from industry or in certain kind of labs, it works for you. Or if someone is much more comfortable being a professor and just having that kind of idea of like writing grants and hence working on this research, so it's just a matter of figuring out what works best for you. So
and it's also, I think it also comes down to what you want to spend time on, right? Of course, like, research works differently, I think. I mean, this also holds for different countries or different institutes, but I think in particular between industry and academia. And there are just different activities you do in academia and industry. I mean, we touched on something earlier where I said I really like that there's more engineering focus at DeepMind, because that's kind of what I enjoy doing to a large extent. Whereas other people might say, yeah, but I really like grant writing. I really like kind of organizing workshops. I really like this kind of bottom-up way of reviewing, being AC, bringing people together, right? And there are people I know that really love that. And yeah, this is I think where academia is strong. And if that gives you joy, at least a couple of hours of your day, then that's great, right? So yeah, I think there's really no right and wrong, and it's like, opinions also change, right? I mean, people switch to some extent back and forth. And yeah, I think that's a good conclusion.
Yeah. And I want to dive deep on academia and research, but I just have one question before we change to that gear is,
Yeah.
I think you have a fantastic blog post where you listed out your experience preparing for the interview for DeepMind. But this is like for the sake of people who might be listening, and also for someone like me who wants to learn like how the process looks like, because I had the chance to like interview for Amazon, which was like a similar kind of experience, but I still want to know. And a lot of people, the reason I normally ask this question is like there is a very fine defined structure for if you are applying for software development engineer interviews or internship. There's a very structured way what kind of things they might be expecting and what are the like sample questions. So like it like before going for the interview, you can familiarize yourself with what kind of expectations you might have. But in research it feels like very open-ended, because it's very hard for me to justify to you what I did in my 5 years of PhD or any kind of length of experience in research and tell you what I bring to the table in just like 1 hour of interview. So that's the reason why people are most curious about like what does the interview look like for a research internship or a research position. Can you shed more of your experience of what was interning at DeepMind for internship looking like for you?
Yeah, good question. So maybe a short disclaimer. So the interviews I did were in 2019. So I did my internship in 2021, but due to COVID, so I was supposed to do it in 2020. So I interviewed in 2019, was supposed to do it in 2020, and then it got delayed to 2021. So it might be outdated to some extent. But in general, I mean, in terms of process, right, if you're interested, it's always good to reach out to people that did these interviews recently, or just to recruiters, right? And just ask. I mean, recruiters are usually they're usually happy to share the process and give a couple of hints of how to prepare, right? And I would always recommend that because processes keep changing. So it's always good to just ask what to expect. On a high level, as you said, in software engineering, big tech to some extent lays kind of the standards of how this works. Of course, smaller companies, different countries have different flavors of that. But yeah, as you said, I think it's a numbers game because software engineering grew that big the last 10, 15 years. There's just a lot of resource on how to prepare. And for ML, this might not be the case yet. Maybe in 10 years, ML is also very big and it's very standardized. For me, it really boils down to kind of two parts. The first part is, I would say, very close to a general engineering interview. This might, of course, be a bit more specific to research because at some companies, these interviews might be conducted by research engineers, by research scientists. At other companies, not. So I remember, for example, at interviewing at Google, my coding interview was actually with a site reliability engineer, right? So not working at all in the AI space or in the ML space. So the interview was also like a very standard software engineering interview. So that's maybe something to be aware of, that it's basically the ML interviews might be a superset of standard software engineering interviews. Not entirely, because there might probably be less focus on system design or something like that. But the coding part, I would say the coding part is still expected to be on par with software engineering. And then in addition, you have the ML specific part. And this is really something, I think it changed quite a bit recent years and is also widely different by companies. But I think on a high level, this is often very similar to coding interview. If you think about a coding interview, what is it? You get a problem. Yeah, you ask questions to understand the problem, to understand edge cases, to understand what the interviewer wants you to implement. Does she want a more a memory efficient version or a time efficient version, right? You ask questions to understand that, and then you come up with a prototype, and you prototype it, and it goes back and forth, and you kind of fine tune it a bit, or you change it a bit depending on new test cases, and then in the end you polish it a bit. You kind of add some comments. You have kind of nice code, right? Maybe you write a test. And ML interviews, in my experience, are similar to that extent. You usually get a problem. Of course, the problem is now might be more open-ended, right? In coding, you might get a problem. Yeah, please implement a doubly linked list and do whatever, right? Because you have to code it, it has to be reasonably specific, but at least you can make it specific by asking. In ML, it might be, okay, imagine you have a problem where you want to classify diseases in MRI or something, right? And then this is of course way more augmented, but I think the approach is very similar. You start asking questions like, what's the setting? Do I have data? Is the data, like, does the data come from the same hospital? What constraints are there? How is it used? And so on, right? You ask questions, you narrow it down. And then usually, of course, the interviewer often has possible answers in mind, right? Like in a coding interview, usually the interviewer knows different solutions to the problem, and it's very likely that you will end up converging to one of them. And with machine learning, it might be similar, but in the end, you come to a point where you propose a prototype. In a sense, you basically propose, okay, I would use method X to do kind of the pre-processing, and then I would use method Y to do prediction, and then we could use that. We could make this useful for the doctor using X, using Z, or whatever. And then the same applies. You kind of discuss this prototype. You maybe find out that, yeah, maybe method X is not that good after all because it's too memory intensive and so on. And you narrow it down, and at some point you come to a point where you're probably asked, okay, now that we have it, can you write down the math of method X for me or something, right? So this is how I experienced it. So I think on a very abstracted level, it's problem solving, only applied to ML and not applied to coding. And I think the tough part is that it's just less clear how to prepare for it. For coding interviews, there are like all these books and stuff. And I don't have a perfect solution for that. But problem is ML is kind of growing, and it's becoming wider and wider. And I think it can feel very overwhelming to learn all of this, right? For interviews, like learn stats and linear algebra and calculus and reinforcement learning and supervised learning, NLP and computer vision and all that stuff. And for me, I think I found a trade-off where I said, okay, these are things that I consider really basic machine learning stuff that, right, if you imagine you sit at lunch and you talk about logistic regression, that's something you expect people to know. Right? You don't expect them to be able to write it down like at night, but you expect them to get the intuition, and like if you sit down with them half an hour, they should be able to write it down somehow, right? And I basically just made a list of things that I consider to be like logistic regression. And kind of brushed up on that and read like lecture notes and books on that. And this was my preparation in the end. So yeah, maybe we will see like ML engineer practice coding interview books in a couple of years, but this is how it is. And I think the most important part, as with coding interviews, but I think in ML even more, it's really asking questions, having a discussion, being open-minded. Of course, you have to know the basics, right? But nobody is killing you if you say that, I don't know the latest kind of transformer model, right? But I can show you like how I would do it with the ResNet, or I can show you how I would kind of do like logistic regression. And like if it's a good approach to the problem, then it's fair. I think the most important is really asking the right questions and then kind of understanding the high level concepts, right? If you ask and you figure out, okay, large part of the data is unlabeled, then go to your toolbox and see what methods do you have for semi-supervised learning or something, right? So it's it can be tricky. I see it, and I think in my blog post I try to basically list down a bit of what I learned essentially, but I don't think there is a blueprint. And it adapts, right? If you don't know a specific method that well, then you are less likely to use it for problem solving. So it might also be not come up. Of course, there are basics and a lot of interviews, I think it's also common to have interview parts which are more about knowledge, right? And so you have to learn the basics. But I think for problem solving, and that's what a PhD is about, right? Problem solving. So communicating that well, I think is at least half of the preparation.
Yeah, and in the end, like if I were to just add my 2 cents over there, is like I think it's more on your evaluating your skills as a research design perspective, because they are like, because in one of the interviews that I had, like the person dived deep onto the idea of like how would I change the design of the research pipeline that I proposed in order to improve the false positive rate of this particular application. And this was like a interview for a company that was using AI for medical applications.
Okay.
So it was like, it was very critical for them to understand what goes onto the model when it has like a higher false positive rate versus the true accuracy, because for them that's the most important thing. So like how do I go, like how do I interpret first of all these results? What does it tell me about the design of experiments or design of model or pre-processing techniques that I'm doing? And to me, like I was able to answer them, but then I was looking back, like because as a master student I was very furious that why can't I apply for research positions? Like I'm equally competent enough. But like after doing my PhD, I now really understand why I actually wasn't competent enough, because I had not done that many of experiments, that many number of perturbations on these results. Now I have done so many experiments, I know what it causes. And one of the other examples was like we published out that work, but it was an interview that was just I think 2 days before the deadline that we were submitting to Mekai. And I was telling to him like what was the new idea that we proposed that got accepted, and it was just like using a novel loss function for like you have like cycle inconsistency when we are using CycleGAN, right? So we propose this translation model that only uses one way. So it's like we are eliminating the need for cycle consistency by some techniques. And he dived so much deep, and actually like I was frank, like because this was like a joint work with one of my friends, but he asked me so many nice questions that I realized that I wouldn't have been able to fake that particular interview if I just read out few stuff like 2 weeks back. It was literally like an interview where like only if you worked on these problem sets or like the formulation of that problem, only then you can answer these questions. So it's like you said, like it's fine if you don't know the latest transformer model or like the best like the baseline transformer model that is out there in 2023, but it's like understanding these very simple things, like what does an accuracy tell you, what does an F1 score tell you, what does any of these small metrics do, what does exactly data augmentation techniques do to the training of model. So like it's very simple. And that's why I think the same analogy is with software engineering interviews, right? So like if they don't want you to implement the best, I mean I'm taking a bad analogy, but like they don't want you to implement the best sorting algorithm, but they just want to see your thought process, as in like what would you do? And there are so many types of sorting algorithm. It depends on what application you have, what resources you have. So
I think that's a great perspective. I think I always think about it in terms of you need to have like a set of tools for problem solving, and the knowledge part is developing the set of tools, right? You have to know like your data structures, or you have to know your like stats and math for machine learning, in order to enable problem solving to an extent. But nobody is like, I mean, like it's really about the problem solving part. So people don't want to see like that you know all the state of the art stuff. But I mean, you know the basics, and you get a new problem, and then how do you go about it? Like understanding what the problem entails and what's relevant. I think that's skills. And I also agree to some extent that that's something that you definitely learn during a PhD. I don't think that you can't develop it doing a master's or something. I don't think it's like an exclusive thing, but I think a PhD is kind of tailored to some extent to develop these skills, right? If you think about like, if you think about the whole process, right? It's all like critical thinking, like all the reviewing process, all the proposals you write, all the paper iterations. It's like trying to come up or trying to apply critical thinking and problem solving to a problem, and to a relevant problem ideally. And I think the tricky part sometimes is distilling that, or kind of showing that ability in like a half an hour or an hour interview, where you might have a bad day, or like the interviewer might have a bad day. So there's so many factors. But yeah, I'm not saying that you should. I mean, people should definitely learn the basics and stuff. And I mean, in my case, this alone took like a couple of weeks, right, to just brush up on data structures, brush up on your stats and stuff. But I think from there on, it's really sit down with your PhD colleagues and and yeah, have a discussion about like some kind of imaginary problem and how you go about it and practice it. And I think that's the best way to prepare in the end.
Yeah. And one other, like, because we're talking about blogs, I think one of the interesting blogs that you had also is about entering your life of PhD, right? So like finding the best institute, finding the best advisor. And I mean, we did talk about, I think, research interest, like you said, like it's like more like an organic process, like you fit into few of the options that you are presented with.
Yeah.
But I think very fantastic thing that you added over there, like, can you talk more about what was your process of finding the best institute or maybe finding the best advisor? Because there are, like, when you start off in this field, everything feels nice, or like maybe you don't realize the red flags that you might be facing down the line, right? So like looking back, what kind of advices, I mean, like if you had any bad experiences, feel free to share, but what kind of flags you would say you people can identify early in their research career?
Yeah, good question. Can I actually ask you before we start? Can I ask you how you found the PhD that you are now? I mean, it's also in your case it seems like a very unique position, right? You're not you did a computer science master's, I guess, but you're not in a computer science department apparently. You're working. So how did you find it?
So for me, so I had a particular fascination that, to me, always the idea of medicine sounded much more appealing to me. But as a person who is scared of injections, like I never approached that particular problem. And this is just me making stupid decisions at the age of 16. So I entered engineering. I loved it, every part of it. But I did one internship. So I was always interested in AI. Like, I mean, I don't want to bore off the whole discussion, but yes, I was interested in the idea of AI, how it can be used on top of your skills as an engineer, as a software engineer, and then apply it to some kind of novel things, right? Like it can, like the idea of AI finding patterns that is subliminal to us as humans was interesting to me. And then I did one internship at Philips Research over here in Cambridge, where they were trying to use. So it was pretty much, I would say, close to an academic lab. Like everything was, I would say it was like a kind of a little bit slow than most of the organizations, but that helped me understand how they are using AI, and they are using AI in actual hospitals. So their models and their scanners are deployed in Long Island, New York, and also Massachusetts. So I did some visits over there, and I could see that, yes, I mean, it is a very small impact, but yes, it has a scope that, yes, people like doctors are interested in this one. And then this was the time I was doing my master's, and because I shifted from India to over here, I wasn't sure that I want to commit to 5 years of a PhD. So I just said, okay, I'm gonna do my master's, and then I'll figure out how ASU, like Arizona State University over here, is like, how does the sentiment of research looks like in United States. And then during my master's, I was just actively also attending a lot of research labs. So there were people from computer vision, reinforcement learning, planning, and I would just go on the Friday lab meetings and just see what the professor is working on, what are the students working on. And I had in the back of my mind that, okay, if I can find a person who is working on medical applications, that would be just like a very additional motivation for me. I would be completely fine if I just worked on a normal vision project. And that's when I think I got connected to my computer science advisor, who is my current advisor now. I told him that I'm interested. If we have funding, I would love to explore options. And I think I waited for, I would say, more than a semester. So I just lost my hope that, okay, maybe I just need to find someone else. And then one day he pinged me that I have a co-PI who is in like she has like more than 6 projects specifically for imaging and medical AI. And would you be interested? And I was like, yeah, that's perfect. And that's when I joined these lab. And then, like you said, like I didn't have many options, but at least I had 6 options to choose from, which projects I want to focus on. And then it became a task to figure out, like, yes, there is a problem. I can solve it just using ResNet, but how do I form my thesis? So that's when we like go into the depth of science, that, okay, we find a problem, we create a problem, and then we solve a problem using thesis. So that was my
did you apply to other institutes as well, or were you mainly looking at the same university essentially?
So after my master's, I definitely applied to, I would say, 3 or 4 universities, like the typical ones that we find. I just applied based on few advisors that I used to follow on Twitter, and I was like, okay, if I get a chance to work with them, it's fantastic. But to be honest, I was much more pivoted to just stay in Arizona. It just felt comfortable over here, that I did my master's over here, and to be honest, at least that's the perception in States, that if you're doing your PhD, the tag of the university doesn't matter that much. It's just the tag of your advisor, or like his or her publication record or reputation in the industry. So I just felt like, okay, I don't have much to look for. I don't want to be too greedy and just make those transitions. So I just stayed put and continued working with her.
Yeah, I mean, that sounds good. I'm hearing a lot of like personal preferences, personal opinions, right? And then the opportunities that you have, the people that you meet on the way, right? It kind of always pivots you to specific, to where you end up in the end, right?
Yeah.
No, for me, I think it's, I think I can, I feel with a lot of these things, because it's like, so in my mind, there's always kind of two separate things. There's kind of personal preference and then the academic stuff. And I think when you asked the questions, you said, okay, how do I find the best institute? And I think that's already not the wrong way to go about it. But I mean, the best institute, this is kind of not, there's no global optimum, right? The best institute for you is very different from the best institute for me. But what I liked about your story very much is that kind of you got in touch with your current advisor by already knowing like people around, and kind of by reaching out and sitting in lab meetings and kind of trying to feel what the culture is like. And I think that's very much what I usually tell people to try to figure out. It's like the advisor and the group that you work with probably has the most impact on whether you can be successful or not, right? Because so the point is, you don't have impact on what's the next hot topic next year. You don't have impact on whether your first paper gets accepted. Of course, you want to write a good paper, but I mean, I'm just saying there's randomness in all of this. So in the same group, you can be successful, but if you start like 1 year later, you can be less successful or more successful and so on. And the key kind of thing that kind of makes it that, or like the key thing that influences like how it feels and how you work every day and like how successful you can be and the opportunities you have, is really your advisor and the research group, I feel. And a lot of course, the problem is that that's, or at least I back then found it very difficult to figure that out, because like you have rankings about universities, you don't have rankings of groups. Of course, I mean, by now there are researcher rankings and so on, right? But there's no ranking telling me, this advisor and this group, it's like it's good, like is a good experience for you, or like makes you successful or something. It's like a very kind of difficult process to find that out. And I like some of the things you did, right? I mean, following people on Twitter, like going to labs. I think this is basically the problem of, first, how do I identify potential groups? I think that's kind of the easier problem, right? I mean, you know, researchers from like friends, from Twitter, from papers. You make a list, you cut those that are not like reasonable for you in terms of like applications or location or what, and you end up with groups. And then, how do you figure that out? You probably apply, and then you have to somehow talk to people, right? And I think the most important part is getting along with your advisor and being kind of roughly on the same page. You will be working with your advisor for like 3 to 5 years. You will be working with him if your papers get rejected, and you will be working with him or her if your papers get accepted, right? And you have to work through it, and like they will kind of read over your papers. They will to some extent determine what you can work on, what not. Your funding. They will also determine like the quality of your workday to some extent, right? How you work, like how, maybe not how long necessarily, but you know, like meeting times, how much interaction you have, how the culture and the group is kind of structured and so on. This is all your kind of advisor to a large extent. And then I think the second most important for me is always your peers, the group. Do you get along with them? And the bonus of kind of talking to them is that they have been working with your potential advisor for a while, right? So like they kind of mirror, like if all of them have good first papers, that's like an indicator that your advisor, your potential advisor, knows how to get people on board, it knows how to get people started, right? If they all graduate in time, that knows that your potential advisor kind of values your time to some extent and that you kind of finish properly and so on. If they kind of participate in workshops very often, or they publish at specific conferences, that all reflects on like not only the group but also your advisor. And that's like, I think I would say the easiest way to find out whether you want to work with a medical advisor. And only after that, I feel, comes the institute. I think the institute and the university is important. It reflects on your CV to some extent, on your personality to another extent. It also influences like the infrastructure you have, the city, the campus. Do you have a lot of external speakers coming in? Do you have like seminars going on and all this stuff, right? But I think this is really the third thing. And of course, it's very likely that at good institutes that are ranked high, you have a lot of good groups. But I think that like this is not a sufficient condition in a sense, right? You can have bad experience at good universities, and you can have an excellent experience and do an excellent PhD at smaller universities, right? It's more like a correlation than necessarily. And then there's for me always personal aspects, and I think I really like that you said you were comfortable in where you are and you wanted to stay. This is a big thing, right? I mean, a PhD, you will have bad days, and if you chose to go somewhere just to be successful, just to have a PhD from the right university with the right name on your CV and the right advisor, but you're not like living there, then these bad days will be worse. That's like just reality. So a lot of people neglect that, but I think it's important. I think it's way better to have, like the point is, it's more important to get through the PhD with maybe not MIT on your CV than to move to Boston, don't like it, and quit your PhD 2 years after, right? And a lot of people neglect that, and I also neglected that, to be honest, to a large extent, because that's what you don't know in advance, right? But it's like a long endeavor, and it can be tough, and it's important to have, like, if it's important for you to move together with your partner or to stay in a specific state, then you should consider that. And of course, then there are also constraints in terms of like visa and all that like legal stuff, which probably for a lot of people, this will just mean that a lot of institutes just like are not on the table. But yeah, this is not sure if that makes sense, but it's a bit my thought process, and I try to write it up in the blog post to some extent. But it's a tough decision. I remember back when I made the decision, and I remember it was difficult. It was like a couple of weeks that you start weighing off things and you start kind of really talking about details. And then if I think back, in the end, it felt very much like a gut decision. It wasn't probably, right? I mean, I did the math in a sense, and I kind of looked what are the pros and the cons and so on, right? But in the end, the main decision was, can I imagine working with kind of my advisor, and do I feel like I can learn something and so on? And so it very much felt like a gut decision in the end. And I think that people shouldn't be afraid to do this. Of course, do due diligence and then feel good with a gut decision. I think that's a good way to put it.
Yeah, I tend to ask this question, but I think in the end, I think there's, even like you said, like even if you do the math, at the end, it definitely feels like the incentive for doing a PhD is very, very less. I think unless you are like 150% driven towards research, and it wouldn't matter if things went sideways, you would be still interested in doing research. Only then I think one can say that, okay, PhD is a good option for me, because there's not one factor that makes you go and jump out of your chair and say, okay, let's do a PhD. Because to be honest, it's a long commitment with low pay. So it's like there's nothing in there for you that can incentivize you. So I think, like you said, like it's like a gut feeling, and if you feel that, you can go for it.
Yeah, I mean, maybe taking a step back. So everything I said was in the context that you want to do a PhD, right? The question whether you want to do a PhD, that's a different question, right? And I think more people should ask that question. I think a lot of people that would enjoy a PhD are not doing one, but I also think a lot of people that are doing a PhD might have different opinions or different experience than they expected. And I mean, this interacts, right? I mean, like you have limited opportunities, and like sometimes it's also just the case that, yeah, maybe you would like to do a PhD, but maybe there's just not, you just don't feel well with the opportunities you have, right? You interviewed here and there, and you just don't feel like working with the advisors or something, and that's fine. And then do something else, right?
Yeah.
I don't think there's good and bad. And then maybe another comment that I think a lot of people neglect, and this is very country specific, I think. In the UK and the US, it's a very different system than, for example, in Germany or in France or so. But the career planning kind of makes a difference in the sense that, yeah, it's like a commitment, it's a different system, it's a different financial setup. And ignoring that is not, like, I'm not saying that go to industry and earn more money, or don't do PhD or do a PhD, but it's something that people should take into account, right? Because I don't think it makes very happy if you have like a bad awakening at the end of your PhD, because everyone told you that, yeah, do a PhD and you always get a job, and then you end up in a tough job market, and then you realize that you just, like, you didn't earn anything the last 5 years, and now you're in a bad spot, right? So if you just do it for like the title or for like whatever, and you don't enjoy the process, or you don't, right? That makes a difference. So yeah, it's like a 2-stage process, right? Think, are you considering a PhD? Yes or no? Is it something for you? And then, like, once you have a rough answer to that question, then comes the next stage. Okay, who do I do the PhD with, and so on. But that's a good point. It's actually, I wrote this blog article in 2018, I think, after I started my PhD, and I updated it recently. And this was one of the sections I added, because back then I neglected it to some extent, because initially I said that very early on I realized that a PhD is kind of interesting for me, and I kind of knew that industry is out there and so on, and I had friends that joined big tech and DeepMind and so on straight out of their masters, but I didn't really consider it, to be honest. I didn't go out and say, okay, let me actually interview in the industry, and then, like, with an offer or something, decide whether I still want to do a PhD. I didn't do that. But I think it's not a bad idea, because then you see what, like taking one opportunity always leaves one opportunity on the street, right?
Right.
So
yeah,
it's really something I feel a lot of people don't put a lot of thought in, and me included. So that's something I in retrospective, I would really say is important.
But then let me have a follow up on this one. Is like, we definitely know what kind of careers one could be targeting if they are doing a PhD, because if you are becoming into like a professor or any kind of teaching roles, you definitely need a PhD, because that's how, like, you thrive in the community. But now we have like an interest in, like, the conversation that we had up till now, like we saw industry has been also involving themselves in research a lot. So nowadays, like, or I would just say, maybe just from your subjective opinion in 2023, do you still think having a PhD degree and working in research and industry adds some kind of value, or is it could be redundant? It could be possible that it's not entirely needed.
I actually remember, like, shortly after I started my PhD, I remember I read it, and there was this discussion, and there were a lot of people saying, nowadays doing a PhD in ML or in computer science isn't worth it. Just go to a company and do maybe not the same research, but work on similar problems there, and you get paid more or something. And there's some truth to that. And there's other truth, and it's a so personal opinion. I know people that didn't do a PhD, and then they were successful in the end, and then they said, yeah, but I think I would have enjoyed doing the PhD. And there are people that did a PhD, end up in software engineering, and then in 20 years they say, yeah, I mean, I wouldn't need it. But this is not how life works, right? You make decisions, you make creative decisions at the current point of time, right? So I think I'm just saying that, like, look around, right? I mean, don't over focus very early on definitely doing a PhD, right? At least, like, look outside. What would be the alternative to a PhD? And then if afterwards you're still you're still convinced to do a PhD, that's great. If you change your mind, that's great. I mean, nobody will punish you for that, right?
Yeah.
So if after 10 years you look back at your PhD and you say that, yeah, I mean, I should have maybe not done one. Then I mean, this is something. I mean, the only goal, at least for me, was always, and this is difficult, right? I mean, I look back now, and of course, I see people around me that didn't do a PhD and are at similar positions. Maybe they do different and so on. But I mean, there's so much randomness involved, and the time dimension is so important that I think the main goal should be that, like, if you do make a decision now about doing a PhD or not, like, think about, like, in 5 years and 10 years, like, would you, like, if the world is different in 10 years, would you regret it, right? So if you're making a decision today to do a PhD because you expect that with the PhD you will earn a lot of money in industry X, but in 5 years industry X is not important anymore, and then you look back and say, yeah, the PhD was kind of a stupid idea, then that's to be avoided, right? I mean, like, I look back and of course I see, like, yeah, I left money on the table, or was like, I did kind of work on my weekends and so on here and there, right? But I'm not, I mean, for me, it was still like a valuable experience overall. I enjoyed working with the people I worked with and so on. Of course, there's no perfect setting, right? It's not that my PhD was perfect, but I'm not regretting it. And this should be, I mean, this should be the goal to some extent, at least for me, right? Looking back, if you look back and, like, you only did it because, I don't know, you thought about this industry or about the title or whatever, and then look back. On the other way around is a bit more difficult. As you mentioned, if you want to be in academia, then you have to do a PhD.
Yeah.
That's I'm not sure if it's unfortunate, but yeah, it's difficult. But I mean, that's also fine, right? If you want to be a professor, do a PhD. If you decide differently afterwards, that's fine, right? Because then you can look back and you can say, yeah, maybe I don't need the PhD for the position I'm in right now, but back then I wanted to be a professor, right? So it was the right decision, and I learned a lot, and then kind of move on, be happy with it.
Yeah. Makes sense. Yeah. No, I think, I mean, I don't have anything to add. I think these are like fantastic points. I think these are like the pointers that people can use to understand their own opinions. Like, it could be different from a person's standpoint or their experience or what stage of career in their life they are. But I think these pointers are really important to evaluate, like, the milestones. Like, I still see that as like the nodes in a decision tree. Like, you think about this one and it could be either yes or no. So these are. And I'm
Why did you
curious
did you start a PhD? I mean, do you want to be a professor, or was it more about the research experience, or?
So, to be honest, when I started my PhD, my goal was to work in industry. And to be honest, this comes from personal opinions, because as a international student, I have a lot of education loans. I feel like, okay, being in the industry would be the best case, because I can help clear my debt and also support my family. But I think in the last couple of years, I'm kind of slightly starting to incline more towards academia. I don't know why.
Okay.
It just feels like, again, to be honest, like 1 year later, if we connect and we talk, I might be still in the industry. I'm still keeping that option open, but I don't find academia to me that much bad. I always felt that I'm not built for academia. I still feel that problem, because I just feel people in academia are like super focused. They're working, I don't know, 16 hours a day. It could be the case even for industry, but it's just very evident from, like, when I look at my professor, she pings me at 11 p.m. and I was like, you have a family, come on, like, I'm a student, like, I can afford that. So to answer your question, it's still a question mark. At least when I started my PhD, I was sure I'm going to be in industry. Now I think I have an open opinion for both of these options.
Yeah, so. But that's great. I mean, you started with a goal, and you're realizing that your goals might change, and you feel like it's you make still a very happy impression, right? I mean, it's not that you regret anything or something. I think that's a good space to be in.
Yeah, but did you have any ever a time where you considered academia, or was it always clear that you want to be in industry?
No, I very much considered academia when I started. I mean, this is of course a bit biased, right? I mean, I was working in academic labs during my master's. I mean, okay, I was also working in industry, right? So I saw both sides, and for some reason, the academic style of working, I just liked it, right? I liked the discussions. I like this kind of focus on, like, publishing, on kind of presenting your work, even if it's like in your group seminars or something. And I found it challenging. I just found it like, and I think there was to some extent some bias to it, that academia is very open. You can like you read papers and you know what people are working on, which is for industry might be a bit harder. So there might be a lot of biases involved. But yeah, I definitely considered academia, and I'm also not against academia of any sort. I think academia has constraints. Industry also has constraints. Both of them has constraints, and at a specific point in time, some of them fit you better than others, and you weigh them against the opportunities you have, or like the joy you have in working in a specific system, I feel. And so yeah, I very much started, and I very much considered staying in academia. And there are some things about academia, about the system, about how academia works that I don't like, that I think pushed me a bit into industry. But also, like, I mean, I had the opportunity to kind of be at DeepMind, and it's very close to research. So, right, I mean, it's like if there would be maybe less opportunities in industry, then academia would have been the more natural choice. I don't think it's like it's a black and white choice, right?
Yeah.
Of course, it's like the older you get, I guess it gets harder to kind of switch back and forth to some extent. But yeah, I think both have their place, and advantages and disadvantages, and you won't have a perfect life in either, but you have to find a good match. So yeah.
And I'm curious, like I think this can be general to academia or industry, but did you ever feel the pressure for like I think like at least for me, I do feel that pressure of like publishing more or getting more citations. Do you feel that game of being more prevalent in terms of numbers on your research rather than the quality? I mean, it can, I wouldn't say that it's not correlated, but like sometimes I do feel just having number of papers and number of citations could not be a good metric for you as a researcher. So first of all, I wanna learn your opinions of like, did you ever feel the pressure? And if you felt that pressure or like that, I don't know, force to do that, like how did you try to combat that?
Yeah, I'll let you know if I figure it out. Because it's a struggle, right? And there are a lot of things coming together, I feel. First of all, with the internet and everything nowadays, it is so easy to evaluate people in terms of metrics, right? We have Google Scholar, Semantic Scholar, and so on. It's so easy to look up and to judge how productive, right? I mean, I'm not immune, right? I mean, if I'm meeting people, I kind of look up their Twitter or their webpage or their Google Scholar, and I look, okay, what did they do during their PhD? And of course, there is like a bias, right? If you see less papers, you think, okay, like what's the reason there? If you see like a lot of papers, you think, oh wow, that was pretty productive. But I think we have to realize that this is, in the end, it's simply a superficial judgment, right? And I mean, I think it's not necessarily bad to have these. I mean, it's hard to get rid of these kind of, and sometimes we need to judge on limited information, right? So
yeah.
But what I learned in the end is that it's a bit like with kind of your CV, right? I mean, you want to have a nice CV and you want to have big names on your CV, or you want to have good experience on your CV, because that's what gets the foot in the door, right? If you apply somewhere, you get kind of invited for an interview based on your CV, but your CV doesn't get you the job. And that's the same with publications, right? You might get more attention if you have like this kind of best paper at a conference, or you have like a lot of publications, or you have a lot of co-authors or whatnot. But in the end, still like the quality matters, and only because like paper X got a best paper award, that doesn't mean that all the other papers are less worthy, right? It's like to some extent, it's like a kind of popularity contest, right? It's like at this particular year, this was a good paper, and it happened to be interesting to a lot of people. There are a lot of other good papers, and they might have gotten the best paper the next year, because then it's like a hot topic. So a lot of these things are, I think, difficult to judge. I think the problem is that because it's so easy to get access to these metrics, I think they definitely play a role, and I think ignoring that would not be a good idea. So I would recommend people to have a Google Scholar profile or Semantic Scholar profile, and to see what like are there mistakes on there and so on. But I wouldn't over-index, right? I mean, I know really smart and great people that didn't get really a lot of citations. I know a lot of people that got tons of citations and are also doing good work, and they don't really care about whether it's like 1K citations or less. So as soon as you interact with people, I think the quality matters and the person matters way more. And I saw how people with like really impressive Google Scholar profiles got rejected from jobs or postdoc positions, and others got it. Because I mean, in the end, we are all human. So if you don't get along with each other, or you're not on the same page, then like it doesn't help you that you have the best paper award here and there. So it's like a mix, and I think it's sometimes we should be more yeah, we should reflect a bit more on like, are we making a decision, like the decision or a judgment we make now, like, is that a fair judgment, or is it kind of based on limited information? And maybe do we want to be a bit more inclusive in that regard? And another thing I maybe want to mention is that Google Scholar and all these metrics, this also reflects culture, right? You have groups where there is a lot more collaboration, which means that PhD students automatically have more papers because they're involved in more projects. And you have labs where there's less collaboration, which doesn't mean that they don't talk to each other. It's just like by construction, people are working on slightly different topics or whatnot, which means they have less overlap, which means that you have mostly your kind of own first author papers and less others. And looking at Google Scholar, you don't see that, right? And it makes a difference. And so, yeah, I think it's, I think it would be, let's say, I don't think it's important, but I think it would, I think as it's there and people use it and it's obviously relevant for making quick decisions and so on, I think it's good to maybe not optimize for it, but be aware of it and align with it. And I think just being aware, there are a lot of easy things where you can, right? I mean, if you publish a paper, publish the code.
Yeah.
Half of your citations might come from your code. You don't know, right? So I think there are if you don't like if you don't like coding and your code is a mess, then you not necessarily want to publish it just for optimizing your citations, right? But if you're like, you like your code and you like open source anyway, so there's like there are like interactions, I feel, and I think it's a fine line. But I think it applies everywhere with even in industry, with your CV, of course, like your kind of the places you worked at, your references and so on, of course they matter. People look at them, people look at your university degree and at your grades and so on, and they get you invited, but you can still do very poorly after you've been invited. So yeah, and I can also feel that it's difficult because as soon as you have metrics, you start comparing. And I think that's something as researchers, we should be, we should be a bit less, or we should be a bit like nicer to ourselves in that a lot of these comparisons are not apple to apple. They're apple to oranges, even though Google Scholar makes it seem as if it's apple to apple, because you can rank people by kind of age index or whatnot. But it's really not. And I think it's important to sometimes step back and say, yeah, but I mean, these are different labs, different things, and so on. And maybe as a last comment, I remember actually on was it my bachelor or my master graduation? So we have, for computer science where I studied, we have a separate graduation. And there was a professor who, an older professor, I think he was actually already retired at that point, and came back. I'm not sure. And he gave a talk on exactly that at graduation. And he said, okay, we have these metrics, H index and I-10 index and so on. And he kind of talked about whether that's meaningful or not. And I always remember back to that if I think about that, because I think it was after my master's. Even then he said, okay, like, don't overfocus and don't like, it's just like a tiny part of yourself. And I think for your mental health, it is good to remember that at some point.
Yeah, no, I absolutely love the idea of what you said is like not over-indexing this information, right? So it's really important. Like, I mean, like you said, it's a good piece of information for learning the citations. You can know how this work can be. Like, it can help you because there are tons of work out there. So it helps. Like, number of citations can help you filter out if the work is good enough, reproducible enough, but not using that as a way to overwhelm yourself. Because if you just try to analyze, okay, compare, like you said, like comparing apples to someone's oranges, it can take a toll on you. So like you
Exactly.
and to be honest, yeah, the ideas of research, like it cannot be just the idea of like working on spite. Like if just because I want to be reaching this milestone of like having this much H index is not definitely a good metric for progressing in your research. So yeah, that makes
So
sense.
most people I met that have a lot of citations and got the best paper what here and there are, I would say, not optimizing for it. They are good researchers. They write good papers. They know the system. They know how to write good rebuttals, reviews, and so on. But they are not doing it primarily, right? They are not jumping on a topic only because they think this will be a highly cited paper, right? It's like, I think the motivation has to come from somewhere else.
Yeah.
Right. You can be aware of it and you can take it into account. But I think if you're just doing it for that, I'm not sure if that would be at least for me, it's not what kind of drives me to some extent.
Yeah.
Yeah, it's a good question. And I really feel with a lot of people with it's like, especially in ML, it's happening so fast. You can be lucky and really have this one big paper at the beginning of your PhD. And it's of course great. I mean, I'm happy for all the people that did good work and it was at the right time and so on. But it doesn't mean that like all the other people like didn't do good work, right? I mean, it's like if you do your own research, it's like, of course you notice all the papers that are highly cited, but we all know very often there are these other papers that are really, really well written and have really strong ideas and that you really base a whole project on, and they don't have as many citations, right? It's like,
yeah, that makes sense. And one of the last questions that I have, and I know we have stepped over the time that I promised for you, so sorry about that one.
I would have interrupted you if it would bother me.
But one of the last questions, and this is just something like, feel free to take it in as much subjective sense that you have, and this maybe also goes beyond the boundaries of what we as researchers are trained to do, is we often see, like most of the times when we have these models like ChatGPT, and this was also the case when I think a lot of large language models came out a few years back, and there is often these media highlights or news highlights that they say, oh, AI is taking over humans, it's going to replace jobs, it's going to do a lot of bad things. Like there is always like a 3% scenario, right? Like some people are very optimistic about AI, some are neutral, they're like, I don't care, and the other one is like very fearful that, oh, AI is creating a big problem and it's going to be like a Terminator scenario. But oftentimes when you see, like, for example, let's say when people talk about ChatGPT, it's just one modality of intelligence, right? So like it's just language. Like we as humans, like when we talk about me and you or any other average Joe, that person possesses a lot of dimensions of intelligence. So first of all, I want to learn from someone who is working in research for a long time to understand, what do you make of such trends? Like people are questioning on Twitter about AGI and other stuff. Have the research community seen at least some kind of tangible research or outputs or results or baselines to make such claims, or is it just purely fictional from philosophical point of view? Like, what if this happens?
Yeah, that's a good question. And to be honest, I don't feel very qualified to give like a very informed answer, mainly because like this question touches on so many points that you probably need to do a lot of PhDs or like spend a significant amount of doing research in a lot of domains to get an informed answer. And I think that's part of the problem, because there is no single person. I think there are many senior people in our community coming close that have like a lot of experience, worked on a lot of different modalities, on a lot of different problems, worked in neuroscience and so on. So I think there are people that come close to having enough oversight to realize what we know, what we don't know, and so on. But I think even then, in the end, you would have to have a kind of an ensemble a kind of committee of people from a lot of different domains giving input on that. And I think that's to some extent what's happening publicly, right? People have different opinions and they voice these through publications on Twitter and so on. And people disagree, people agree. We don't know yet where it converges. But I think people have very different perspectives because they have different experiences. So one thing, for example, as you asked the question, it's just language. Yeah, it's just language, but language is like a significant part of how we define intelligence, right? I mean, if you think about it, whenever you are judged on your intelligence, it's in writing. Or like, let's say in terms of academic intelligence, right? There are, I mean, even the question of what is intelligence and what different forms of intelligence there are is like a very complex question that I'm not an expert on, and I don't even have an idea where to start. I'm just saying that, and I don't want to blame you for that, right? But just language, it's like, it entails a lot, right? It's like how you are judged as an academic, how your grades are judged, how you are judged as a child. It's all like in terms of like what you can say and what you can write. And yeah, then you have people that have different opinions, and we need to discuss them. And I hope that there might be a consensus, and people might apply a label to it. And this label might be near AGI, AGI, narrow AGI, or however you'll call it. And I hope, or I know that people are thinking about these problems, and there are people thinking about these problems that are smarter than me or have more experience on that topic. I just find it, I'm generally an optimistic person, which, I mean, I work in safe AI, so I'm aware that there are a lot of problems, and I feel that we have to make sure that we address these problems, that we realize the opportunities of technology and limit as much as possible the risks. I very much believe that. And you can quote examples from the past where humanity was good in doing that, and research succeeded in doing that, and research didn't succeed. And I don't know the outcome yet, but I'm generally optimistic that there are a lot of smart people working on that, and there might be hiccups. I'm not too concerned about rogue AGIs coming about us tomorrow. But on the other hand, I mean, ChatGPTs and similar LLMs were surprising to a lot of people. I mean, let's be honest. I didn't anticipate it. A lot of people didn't anticipate it. I think that's the result of a lot of people working in parallel on all of these things and trying to figure out problems and questions, and coming up with their own mental model of how to label things and how to call things and how to evaluate capability of things. And then we kind of need to converge or like discuss all of these different ideas. I think of it very much in terms of like in a research group, right? If you describe, as you said earlier, if you describe a problem to different audiences, you have different mental models, and I mean, people have different connotations to AGI or intelligence or whatnot. But yeah, as I said, I'm optimistic, and I really enjoy the discussion. I think at some point the discussion might be a bit fierce. At some point it might lack a bit rigor, but I mean, that's the nature of opinions and discussion, right? So I think as long as we can make sure that there is a process, that we can find a good process to it, and that we include relevant people into the discussion, which by now, I mean, one reality that I find very exciting is that a couple of years ago, this discussion happened within the ML community, maybe within the tech community, but now the discussion is happening beyond the tech community.
Right.
And I think we should, I think it's important to take that into account, that not only tech people are working with these tools now, but like everyone on the world can. And so, it's important to get opinions from governments, from regulation, from industry, from private persons, from all sorts of parts of the society.
Yeah.
And that's what's happening.
Yeah, I totally agree, and this is something that even I had the same summary. If somebody asked me this question, is the idea of like how people's experiences shape how they comment on it. Like if I were to show, like I think when ChatGPT came, like to be honest, like when it released. As a researcher, I knew like the backbone of like GPT models, because we have been following the GPT models from the last 3 years or even more than that. So like when it came out, to me it was like a surprise, like why people are so much surprised about it, because when you interact with them, like we know it's like a next word predictor, so it's just like maybe completing few sentences, and at the end, like because it's trained very nicely, the data is nice, so it can have much more coherent sentences and it can hold a conversation. But when I talk to a few of my friends who necessarily do not understand how these models work, to them it's like a completely magical scenario, because yes, before Google couldn't do it, like, or any kind of like Google search couldn't do it, and now there's this one tool who can like talk to you, who can provide information, good or bad, that doesn't matter. But it's like it's like just this whole new dimension that got added. So I think, yeah, having like, and just because you have different experiences, it can also bring different opinions, how you interpret this technology in your life versus my life, how it incorporates. So
yeah, I think that's a good way to put it. And I'm not sure what to add there, but it's a good question, and it's like a very loaded question nowadays. So I think it's important to be differentiated to some extent and acknowledge that many people have different opinions, and that most of these people may as well have this opinion and voice it, and of course subject to respect and everything. I like the discussion. It's like people are figuring out what works not, what are limitations, what are risks. I remember for in terms of safe AI, for example, I mean, people acknowledged that it was important, but it was still a very small part of the community for a long time. And suddenly, because it's more widely applicable, people are realizing that there are a lot of risks, and I really, really appreciate that people are talking about it, and there are discussions happening with all sorts of stakeholders to limit risks. And personally, I really appreciate that, because it's of course part of what I worked on for a long while, and of course it's not necessarily adversarial examples or whatnot, but all of this prompting and so on, and kind of the societal impact. I think it's important that we have more interdisciplinary research into that and talk to people outside of ML and computer science. And as you said, right, talk to people that didn't study computer science and get an impression of what they think, right? What do they use these tools for? And LLMs is only one example, right? I think the same is also with all the image generation we had the year before that, or maybe not a full year, but this was also very surprising to me, because we knew that we can generate images and stuff, but for some reason we never we know, of course, there are applications down the road, but I found it very interesting to see what people actually do out of it, right? And what risks are associated with it and so on. And I think it's great to see that. And of course, I hope we limit the risks as much as possible. I mean, that's what I'm working on most of my day. But I also really like to see what people are doing with it, right?
Yeah, makes sense. And one of the last questions that I have for you when I normally sign off a speaker is just maybe open-ended, is just like what kind of tips would you give to someone as a young researcher? Because most of the times when I post of these podcasts, it's like I get a very same template of questions. It's like they are interested in AI because yes, AI is a very lucrative field, it's very interesting, like you said, like in our first questions, like the application part of it like seems magic when we get started with it, but they are often confused about like how to get started, right? Like, I mean, we did cover like what you said, that you just get started and then whatever options you have, you navigate through those options. But if at all you would have advice for people, you might feel like people get often stuck in that particular question, is like how to get started, right? Like the mathematics part is really hard, or maybe should I do a graduate level course? Should I do a certification? Or is a better option is like just going into an industry and then maybe hoping for like an ML project to work on, and that will indirectly help me up my skill. So what kind of advice you would give looking back to a person who is just interested in AI?
That's a very wide question. I don't think I have a good answer. What led me there is, I mean, I would say be curious and try to learn, and try to learn in the capacity you have. And it depends on what the goal of what goals people have. But yeah, if your main goal is to I don't know, somehow break into ML industry, then you will have a very hard time if you are not curious about ML and wanting to understand it, and be kind of not only willing to learn but also like curious to learn, right? I mean, why do things work and how does the math work? And I mean, this applies probably for a lot of disciplines, right? It's not about ML, but I think ML is interesting because tech in generally is very open in the sense that there are lots of resources very easily available. You can get started very easily. And I think right now this also happens to ML to some extent. The threshold is lowered, and which makes it easier for people to, independent of where they are at university or in a job or whatnot, to play around with it, try things out, ask questions, get excited about it to some extent. I don't think I have any. I don't think I have any more advice. I think it would get too specific to people. But I think the combination of, if people are interested and want to learn about it, then I think it's a good time. And I think the important part is to find the right environment or find good resources. And I think this might be hard at the beginning, but I feel it's getting easier with kind of a lot of the resources that kind of companies and academia and so on puts out there. But this really depends on where people are coming from, computer science background or not, and so on. I'm not sure if that was a very satisfying answer, but
No, I think even regardless, I think throughout the whole podcast, you had like fantastic advices overall. I think that's why I think this question was a redundant on my end, but I think you had like fantastic advices in general. So yeah, that makes sense.
I think one thing to say is that we of course always talked about PhD in industry. It kind of always assumes that people are always in the discipline to some extent. And I think that makes things way easier. But I don't think, I mean, there are people that have I don't know, astrology or model airplanes or things like that as a hobby, right? And I really hope that people develop an interest in ML as a hobby, and I think it's a good time to start that. I mean, play around with these tools. If you are a programmer, try out kind of all the language models. If you are a creative, try out the things, and then afterwards it might automatically kind of develop of how you learn and what the people around you do. So I think that's definitely kind of something for if people are not already in a computer science degree or already in a PhD, right? From where it's more specific. I also don't think people have to have a career in ML to be interested in it. Right? It's like, programming or like using computers and getting around with like IT stuff is useful everywhere, and people have an interest in it outside of their work. And I think the same should be possible with ML and AI right about now, and it might get more accessible the further we go in the future.
Yeah, I think the beauty of ML lies in the interdisciplinary applications of it. So I think having more people bringing in their own expertise and knowing certain parts of ML and then applying it for something truly novel. That's where I think the beauty of research happens. So
I think there are so many, with the LLMs and also image generation. I think we saw so many people using these tools for things that no ML researcher ever really thought about.
Yeah.
And it doesn't need an ML. It doesn't even need a computer science degree to do that, in my opinion.
Yeah.
Yeah.
True.
It also brings new perspectives, right? I think it's good if people can be part of the conversation that's going on and be more informed, and
yeah. But yeah, on that note, I think those were the topics that I think I was hoping to cover, and I think it was fantastic. I think there were very, very nice insights that you brought in terms of like how research career in industry and academia looks like. How did your personal opinions affected your particular career path? And to be honest, yeah, you were completely honest about like how like things are not exactly like starting from point A to point B. There are lots of things that happen to you, and you just adapt to that and make decisions on that. And also we had some very nice discussions on generalization and robustness, which again to me also was interesting because a part of my particular chapters on my thesis is focused on that, so it's very interesting. And yeah, I'll be leaving a link to your blog articles that we definitely talked about, but I'll also leave a link to your homepage so that people can check out like the other articles that I didn't get a chance over here. But I think there are some fantastic topics that you have, and it's like a very nice diary of yours, because I think I don't know, I think it's from 2016 or 2017, right? Like, or maybe earlier than that. Like,
so
you have been maintaining.
I started even before that. I did a lot of web development before that, and that's where I started the blog. But yeah, it's it's in retrospective, I also sometimes go back and see it's a very interesting progression of the topics that I was interested in and things I was learning.
Yeah. But yeah, I'll leave a link because I think it's very useful for people like us to learn like it gives you like a pseudo trajectory of your thoughts, and it just helps resonate that I'm not the only person thinking about these things. So but yeah, apart from that, I think I hope listeners find this useful, and maybe if they have any specific questions, they can reach out to you in any ways possible. But apart from that, it was a fantastic conversation. It's good to talk to someone who has been a student recently, so it's like it resonates well, so that you can relate both the sides of research. You can see how the overall picture of research looks like, but also you have a pretty good grasp of like how the nitty-gritty details of implementation look like. So it's very useful.
I think it still feels closer to the details and the grad student life. But yeah, it was definitely, I enjoyed the podcast. I hope I wasn't rambling too much, given that we were like a bit over 3 hours now, I think.
Yeah.
But yeah, it was definitely great. And thanks for having me. Thanks for the questions. And I hope people find it useful to some extent, or find bits that are useful that they can take some value out of it.